Hello and good morning to Madam Yo. My name is Muhammad Firoz bin Muhammad Daud. My registration number is 01DKM19F1202. I would like to talk about the Rankine cycle. Rankine cycle is an ideal cycle if water passes through the four components without irreversibilities and pressure drops. The ideal Rankine cycle consists of the following four processes as shown on the TS diagram. This is the TS diagram. 1, 2 isentropic compression in a pump. 2, 3 constant pressure heat addition in a boiler. 3, 4 isentropic expansion in a turbine. 4, 1 constant pressure heat rejection in a condenser. And this is PV diagram. Process 1, 2, 2. As shown in the diagram above, saturated water from a hot well at point 1 is isothermally transformed into dry saturated steam in a boiler, and heat is absorbed at constant temperature T1 and pressure P1. The steam is now in a dry state as seen at point 2. T2 and P2 represent the temperature and pressure at point 2. It is comparable to the T1 and P1. The PV and TS curve 1, 2 depict this isothermal expansion process. The heat absorbed by water during the isothermal expansion process is denoted by HFG1, which is comparable to HFG2 as a corresponding pressure P1 and P2, since P1 equal P2. Second, process 2, 3. The turbine is now filled with dry saturated steam with a dryness proportion of time 3 of x3. Steam expands isentropically, lowering pressure and temperature from P2 and P3 and T2 and T3. There is no heat provided or rejected during this expansion. As a result, there is no change in entropy, and the curve from 2-3 falls down as shown in the graph above. Process 3-4. Wet steam enters the condenser at this point for condensation. The condenser rejects heat at a constant temperature T3 and pressure P3 until all the steam has been condensed into water. T3 equal T4 in point 4 condition. As a result, the PV and TS diagrams have a straight line, and the heat rejected by steam is known as latent heat, which equal X3HFG3. Process 4-1. Water is now injected into the boiler at point 4 for warming. Water is heated to a constant temperature T1 to T4 to T1, and the volume in the boiler from P4 to P1. The pressure rises. On the PV and TS diagram, this operation is depicted in graph 4.1. The sensible heat or liquid heat corresponding to the pressure P1, which equal to sensible heat at point 1 minus sensible heat at point 4, is absorbed by water throughout this procedure. Next, I will talk about Otto process. Process 1-2, isentropic compression. This process is also known as the compression stroke, where the piston of the cylinder compresses the mixture of air and the fuel. Process 2-3, isometric addition of heat. This process is also known as the power stroke, wherein the spark plug of the engine ignites the compressed mixture of air and fuel. Process 3-4, isentropic expansion. This process is also known as the exhaust stroke, wherein the piston of the engine pushes the cylinder up, thereby releasing the burning gases. Process 4-1, isometric rejection of heat. This process is also known as the intake stroke, wherein the piston of cylinder move down the cylinder, thereby resulting to an intake of air. Next, 4-stroke diesel engine. This is the diagram. Process 0 to 1, suction process. In this process, the inlet valve open and suction of air take place at atmospheric pressure. It is called as suction stroke. Process 1-2, isentropic compression. The air sac is now compressed isentropically. Due to the compression, The temperature of the air increased to such level at which the diesel gas ignites. It is called as compression stroke. Process 2-3, constant pressure heat addition. At the end of the compression, the piston is at TDC and at this time the diesel fuel is injected into the cylinder through fuel injector in atomized form. At this atomized diesel fuel comes in contact with hot compressed air. It gets ignited and combustion process start. The combustion of fuel adds heat to the engine. Process 3-4, isentropic expansion. The combustion process adds a large amount of heat and this creates a large force on the piston head and it moves downward from TDC to BDC. It is the power stroke. Process 4-1, constant volume heat rejection. The piston is at BDC and coolant comes in contact with the cylinder walls and take away heat from the engine and make it cool. After that, piston move upward. Process 1-0, exhaust process. In this process, the piston move from BDC to TDC and exhaust valve open. All the burn gases left in the cylinder escape out through exhaust valve. It is the exhaust stroke. The last is Brayton cycle. This is the diagram, and 1-2 is a isentropic compression. The gas is sucked from the atmosphere to the engine combustion chamber. The compressor compresses in such a way that there is no change in heat. Due to the compression process, the temperature and pressure of the gas become very high but decrease in volumes. This process is also known as reversible adiabatic process. Isobaric heat addition 2-3. The compressed gas is transferred to the combustion chamber. Due to the heat addition, the compressed gas ignites and this ignition process further adds heat to the gas. During this whole process, the enthalpy of the working gas increase but its pressure remains constant. Isentropic expansion, line 3-4. In this stage, the heated compressed gas enter into the turbine area, where it expands. As the gas expands, its pressure and temperature reduce, but entropy remain the same. In this process, the gas works on the turbine and turns the turbine blades. This blade rotates the crankshaft, which further move the vehicle wheels. And the last is isobaric heat rejection, line 4-1. In this isobaric heat rejection process, the unused heat of the gas expelled via heat exchanger due to that temperature of the gas decrease, but pressure remain unchanged. That's all for me, and thank you.